Where my not mark. Fine. Now you know well IPv4 and IPv6. Fine. Now we have to use these two versions of IP address. And for this, I'm just going to draw two networks. One will be based on IPv4 and second will be based on IPv6. Fine. Just for the connectivity of few machines, which topology is used now in these days? Simply a star topology. Fine. Now, what is this? Switch. Fine. Suppose this one is switch 1. Now I am connecting few nodes. Fine. And this network is based on IPv4. Again, there is one more network. Node 1, Node 2, Node 3, and Node 4. Fine. And it will be based on IPv6. At the same time, if you will see two networks, one will work on IPv4 and one will work on IPv6, then you can easily compare how we have to configure it. How we can define different networks. Fine. First of all, IPv4, you all have given good presentation on IPv4. Now, for this network, just give me a IP series, IP network, IPv4 network. Just give me. You can take a network from class A, class B, or class C. Any.
101, 101 north. 101 north.
10. Okay. 10. 101. 101. Dot 255. 36. Network. See, just to take a simple value that can be easily digested by every student. 10. Okay. 10. 10.0.0. Simple. 10. Because 10 belongs to class A. And in class A, only first group is used to define different network. Okay. So this is the first network. And now in this network, three groups are used to define different hosts. So these are known as host bits. Fine. Then the first value will be 0.0.0, and the last second value 10.0.0.1. Then 2, 3, 4, 5, 6 up to 255. Then 10.0.1.1, 10.0.1.2, 255. In this way, we can reach 10.255.255.255. And the second last value will be 10.255.255.254. This will be the network IP address, broadcast IP. We cannot use it. So the valid IP host range is this. And what will be the default subnet mask? .255.0.0. Okay, fine. This is network 1. Now, second network. We can take value like 11. There is a change in network side. That's why this is a different network. 11.0.0.0, 11.0.0.1, 11.255.255.254, 11.255.255.255. Network IP, broadcast IP, valid host IP. And subnet mask 255.0.0.0. Fine. Now these two are examples of IPv4 in IPv4 class A, and in class A, there are two networks. One is 10, second is 11. Is it clear to everyone? Fine. Now I am going to use few IP addresses for configuration of these nodes. So at first node, if I'm taking IP address from this network, then the value will be 10.0.0.1, 10.0.0.2, 10.0.0.3, 10.0.0.4. In this case, all these nodes will communicate to each other. Fine. Because these nodes are in the same network. Why these nodes are in the same network? Because at all nodes, the class A IP address has been configured, and network part of all these IP addresses are same. So these all nodes will communicate to each other. Fine. Now I'm going to make some changes with these two nodes. I'm going to put different IP address, like for this node 11.0.0.3 and for this node 11.0.0.4. Then what will happen? In this case, these two nodes will communicate to each other, and these two nodes will communicate to each other. Means in a single physical network, there are two networks. Fine. Is it correct or not? Is it digestible for all of you? Clear? This is IPv4 concept. Now, we have to move to IPv6. In IPv6, 128 bits are used, total 128 bits. Clear? And out of 128, how many bits are used to define network? 64. First 64 bit will define a network, and the last 64 will define host. And in in IPv6 there is no class, and in IPv6 in every network every IP address is a valid IP address, because there is no concept of network IP and broadcast IP. I have given all these theoretical knowledge to us. So again, I'm going to do the same thing as I have done in IPv4. Okay. Now, just IPv6 is represented into hexadecimal number. Just I'm going to write a very simple IPv6 address. For first network 1, 2000 colons 1234:1234:1238. Fine. These are the first 4 part of IPv6. First 4 part means every part has 16 bits, means total 64 bit. Okay. Now, this is the network part. And in host, 1234, 1234, 1234, 1234. Fine. This is the very first value, and it is valid also. So the last value will be 2000:1234:1238 and F. Fine. Correct? There is a silence in that class. This silence shows that everybody is understanding. And the second phase of this silence is nobody is understanding. What is correct? First case or second case? Both cases. Why? You are told both cases, Mike. Hello. What happened? You have told both cases. I have explained it very proper. Have you missed the class? If anybody has missed the class, then it is not digested. Because IT is a concept. Look, you all are making some applications, program, and that small program, you are facing too many issues, too many bugs. Huh? Hardly you are able to make it successful. But think about all those developers who had developed this program, IPv and IPv. What is the length of that program, this program? How many logics are used in this program? This program is so good that on the basis of this program means this protocol, means this IP address, the whole world is running. If there is no IP, there is no communication. Think about those programs. And you all, you people are not able to understand this programming logic. This is not programming logic. Programs output only. If I will told you, okay, fine, you have to define IP10, IPv10. We are unable to understand even the output of the program. And you are telling me to develop a new program that will be IPv10. Yes. Sorry? Before IP version 6, there is a voice communication. There is no data communication. Initially, for data communication, only MAC address can be used. Fine, different values are used. This is not only the logical identity. For this identity, IP, this is IP protocol, but IPX and AppleTalk is also present. IPX and AppleTalk. AppleTalk also gives the logical identity like IP address, but it is only used at Apple machine, Macintosh. If we'll have to study all these things, we will be heavy confused, my dears. Hardly we are understanding these values. Now you are talking about there are some more protocols that is used for logical identity, means logical address. Doesn't matter. First of all, try to understand. This is based on IPv4, and in case of IPv6, I have already taught you that there are 64 bits. First, there are 64 bits that represents network, and the last 64 bits represent host. And it is based on a hexadecimal number. We have done an exercise for your serial number, roll number, by which I have given you idea how you can count in decimal number. Because if you are able to count in, sorry, not decimal number, hexadecimal number. If you are able to count anything in hexadecimal, in that case only you will be able to define different IPv6 addresses at different node. Fine. From that counting, this value becomes this value. 000010002345678 A B C D E F 001011121314151617181910 2021222324252627282928 2B 2C 2D 2E 2F 30 and so on. We all have done exercise on this. Yes. In this way, definitely we will reach F. If this group is now over, then we will increase value of this group by 1. Then it becomes 0001, and then again all 0 to all F. Then the final value will be all F. Fine. And in case of IPv6, we do not use any subnet mask. In place of subnet mask, we use only subnet prefix length. And in subnet prefix length, we write the number, total number of network bits. And the default network bit in IPv6 is 64. That's why subnet prefix length, I'm just writing it in short, subnet prefix length, SPL. This is not the abbreviation. 64. Now, from this network, I'm just going to take value. I'm going to write only the last group value, because otherwise it will be too long. Now, dot 0.0.0, not sorry, colon, last value, all 0, then colon 0001, colon 0002, colon 0003. Getting a point, what I have said. Now, in this case, all these nodes will communicate to each other. But no, just take second network. Second network, 2000 colon 1234 colon 1 colon. Now, we have to make any change. I'm going to take value 000B. Simple. A then B. Now, 1 2 3 4 1 2 3 4 1 2 3 4 and 1 2 3 4. This is the very first IP of this network. One, two, three, four. 1 2 3. Oh yes. And again, the last value, 2000. Fine. In this case also, subnet prefix length will be 64. Now from this network, here I'm going to take IP address. Fine. And we will assign like this. We have changed change at these two nodes only for second network? No. For this node, I'm just going to write complete full IP address. 2000 colon 1234 colon 1234 colon 123A colon not A, B. B colon 1234 colon 1234 colon 1234 colon 1234. Correct? 2. Now for this node, 2000 colon 1234 colon 1234 colon 123B colon 1234 colon 1234 colon 1234 colon 1233. Just imagine. If you are understanding it, then it is only visible. You are not understanding it. Oh, fine, there is multiple dots. And when there is a multiple dot, there is a concept of line. This is a straight line only.
Y is equal to mx plus this.
Clear? Now, fine. In this case, now these two networks will communicate to each other. Sorry, these two networks. These two nodes will communicate to each other, and these two nodes will communicate. Fine. Now see. Now at your whiteboard, there are two networks. First is based on IPv4 and second is based on IPv4. Everything at a glance. We have given approximately 6 to 7 classes to understand IP address. And the final result of last 3, 4, 5 classes is this. Now we all have to implement it at a real scenario. And we have to see the output. Really, these four, in first case, these four nodes are communicating to each other or not. In second case, these two nodes are communicating to each other or not, and these two. Same thing we will do for IPv6 also. Fine? Yes. So, my dear all students, please note down it properly. We will see a lab on these two concepts in next session. Yes, please.
This IP address, the second IP address of health network is correct.
In case of IPv6?
Yes.
Yes, it is correct.
Sir, because there is only 3 and how it will
Second.
No. Oh, it's a mistake. Actually, I had to write multiple F. That's why. F. Note down it properly. You all will be happy when you will do some practicals on this. And now you all will be able to understand the IPv6 of your phone. Fine. I'm just going to mark your attendance.